Okay, so we're looking at all of our stuff isn't always given to us in graphic form. We can do this with a table as well. So we know that our function is continuous, so life is good. If our function is continuous, what does that mean? Yes, that means it is integrable. You can integrate it. I can't say that word. Such that f of x is always greater than 0, so that's nice. So we know that all of our areas, our function values are always positive, so all of our areas are going to be positive as well. And then so we have this table. Approximate 0 to 3 of f of x using the numeric method based on the data. So that means you're doing like a left end or right end Riemann sum. I'm going to use, hold on a sec, let me think. All right, so I don't remember where I left off, but so we're going to approximate from 0 to 3 of our function using the information in the table. So I'm going from 0 to 3. How many intervals should we break this into? Well, the data usually sets up pretty nicely for us. So if I go from here to here, then from here to here, 2, 3, 4, 5. So I'm going to make 6 intervals. So I want to do the left end, right endpoint, midpoint, trapezoid. So let's see how we can do here. So let's start, see if we can save ourselves some time. So we want to do this part A. Let's do the left endpoint first with how many? With 6 intervals. Okay, now this is an approximation. So we need to use the approximately symbol. Do we have a common gap? Yeah, each one of these is a distance of 1/2, right? So this is 1/2. I'm going to go with 0.5. This is 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 0.5. So we know that our rectangles that we draw are going to have a width or a height of 0.5 for all of them. And then I want to evaluate the left edge of the interval. So the left edge is my function value 2. The next interval, my left edge is 0.5, so that's 4. So that's 1, 2. This is my third interval. The left edge is 1, so that's 6. The left edge is 1.5, so that's 7. The left edge is 2, so that's 4. The left edge is 2.5, so that's 1. And you should have 6 numbers. 1, 2, 3, 4, 5. Yeah, you should have 6 numbers, right? So when I calculate this, notice now I'm going back to an equal sign. 0.5, so that's 10. That's 17, that's 20, that's 24. What's half of 24? 12. All right, let's do a right endpoint approximation. So we're going to call that R sub 6. I would encourage you to try to pause and do it on your own. It's up to you. All right, so I would get a 0.5. And now I'm using the right ends of all of these intervals. So it's going to start at 4, 6, 7, 4, 1, and 5. So 0.5 times, that's 10, that's 20, that's 27, 27 cut in half. I don't know. I'm going to just leave it as 27 over 2. Now let's try a midpoint approximation. How long are my gaps? My gaps are still 0.5. Now I want to evaluate the midpoint of these. Hold on a sec, sorry. All right, I forgot. When we want to do a midpoint, you can't estimate. You've got to change your intervals here because I can't estimate. I have no idea what happens in between these two values. So instead of having an M6, I want to try to divide this so that I have midpoints. So I'm going to use this to this as one interval because it has a what? A midpoint. I'm going to go from here to here because it creates a midpoint. I'm going to go from here to here because it creates a midpoint. So now I'm not going to calculate m sub 6 because I didn't make 6 intervals. I made 3 intervals. Now, how long is each interval? How wide is each interval? This time the width of the interval is 1. And my midpoint values are those function values in between. So that's 4. My midpoint, then that's 7. My midpoint, then that's 1. So that's what? That's 8. That's 12. My midpoint approximation is 12. Does that make sense? And then finally, we're looking at the trapezoid situation. The trapezoid situation, yeah, we can go back to 6 at this point because, yeah, we're going to get a better estimate if we go back to 6. I don't need to find the middles of these. All right, so let's see. First of all, there's a 1/2. That's because the trapezoid formula is 1/2 height times base 1 times base 2. Then there's the height. So our heights, our widths, our intervals are also 1/2 times, and now I'm going to try to save us a little bit of work here. So when you do base 1 and base 2, you start at your interval and you're basically just adding those together. So I'm going to go 0 plus 0.5, right? But what's my next interval going to start at? 0.5 again. So there's going to be 2 0.5s because this interval ends at 0.5 and then begins. There's going to be 2 1s, 2 times 1. There's going to be 2 1.5s. There's going to be 2 2s. There's going to be 2 2.5s. And then there's only going to be 1 3. All right, so what does this look like cleaned up? So that's a quarter times this 0 plus 1 plus 2 plus 3. Oh, that's fun. Plus 5 plus, oh, that's sad. So what do we have here? That's 5, that's 8, that's 10, that's 14, that's 18, 18 fourths. I paused because I was like, hey, that's something screwed up there. And I realized what it was. I used the x values instead of the function values for my, from the table. So this should be 2 times 4. No wonder that came out so interesting down there because they only went up by 1. So this should be a 4. Then it should be 2 times 6. There's 2 times 7. I'll write it above it. I think it's a little more clear. 6, 4, 4, 1, 5. Oops, I forgot to do this one. That's a 2. So let's see if this is a little bit nicer. So I still got my 1/4 out front. This is going to be 2. I'm going to run out of room for sure. Plus 2, so that's 8. Plus 12. Plus 14. Plus 8. Plus 2. Plus 5. Let's see here. So that's 20. That's 30. That's 44. That's 49. That's 51. That's better. All right, prepare to be annoyed. So there's a nice little shortcut here. If you ever have to do this sequence, watch what happens when I add the left hand and the right hand estimates together. So 12 plus 27 over 2. I need a common denominator, so I'm going to make this 24 over 2. 24 over 2 plus 27 over 2 is 51 over 4, which is the trapezoid rule. So it turns out that the right-hand rule and the left-hand rule averaged, not average, added together ends up giving you the same as the trapezoid rule. All right, so that was all of A. Let's squeeze B in here. So I'll get a different color that'll stand out, hopefully. Part B, could any of these represent the approximation of the area of the region? Yes, of course. Why? It only works because f of x is greater than or equal to 0. If they didn't give us this, then we couldn't say that because we didn't know if these values would go into the negatives, and so we couldn't be sure that it could represent those areas because those would go up and down, back and forth, back and forth. All right, can you approximate f prime of 1? Let's go back to the old time machine. There are 3 different ways that you could approximate what f prime of 1 is. Pause it, see if you can remember how we did that first semester. All right, let's see how you did. F prime of 1 could approximately be, remember how we did this? You could use these two, you could use these two, or you could use these two. Oh, it kind of looks like a smiley face. Oh, dang it. You could use these two to give an estimate, these 2 points. You could use these 2 points to give you an estimate, or you could use the 2 points that are around it. I like to do the 2 points that are around it. So you could do 7 minus 4 over 1.5 minus 0.5. So I'm just doing the slope formula. Notice that turns into an equals. This is the approximate. 7 minus 4 is 3. 1 point, that's 1. So that's one approximation. Another approximation could be, we could do f prime of 1 is approximately, let's say I compared these two together. So that would be what? 6 minus 4 over 1 minus 0.5. 6 minus 4 is 2. 1 way, that's 0.5. 2 minus 0.5 is 4. And then the last one, can we make it happen, Cap'n? Let's try to squeeze it in back here. I could also do f prime of 1. And I could use these two, 1.5 to 1. So that would be 7 minus 6 over 1.5 minus 1, which would be 1 over 0.5. Flip and multiply, so that would end up being 2. Any one of those are good approximations, or based on what we have, the best approximations we can make of f prime of 1. All right, so now we're getting down to this is where our intervals aren't as nice anymore. So we know that it's a continuous function. We don't know that all the function values are positive or negative, so our hands are a little bit tied here. We don't have as much help as we had before. We want to approximate from 1 to 8. Be careful. You got to be careful that you're looking at the right interval. That's why he said reread the definite integral again. So I'm going to try to do my 4 approximations, my estimates, I should say. So we're going from 1 to 8. So I'm going to highlight that all together. 1 to 8 is what I'm trying to cover. So what would be one possible breakdown? I could go from here to here, then here to here, then here to here, then there to there. Okay, so that's 4 intervals. Now be careful when you're doing this, though, because look at your intervals. Look at our intervals up here. What were the x values always changing by? 0.5, 0.5. This is not quite as nice. We got to be a little bit more careful. So we'll take a look at that as we're going through. So let's do a left end estimate. So part A. Left hand, we're doing 4 of them. Would approximately, now I can't do this nice little factor out the common interval because we don't have that each time. So how I'm doing the left side, so here's my interval, I'm going to the left side. That's going to reach a height of 3 times, how big is my interval? 2. Plus, now I'm in this, so this is interval 1, this is interval 2, this is interval 3, this is interval 4. Now I'm in interval 2. I go to the left-hand side. How high is my function? 3. How wide is my function? Also 3. I'm in interval 3. I go to the left side. How high is my function? How tall? It's height of 1. But it only goes a width of 0.6. And then the last interval, it goes to a height of 5, but it has a width of 1.4. Hopefully that's going to come out in the wash, but I don't think it's gonna. Oh, well, we'll see. All right, so that's that. That's 6 plus 9 plus 0.6 plus 5027 decimal time. So that's what? That's 14. That's 14 and 9 is 23, 23.6. See if you can do the right hand. All right, we're moving on to the right end. I just watched Corpy. He did a nice way. He kind of explained it. He put the gaps in there first. He says, all right, I know this interval is a gap of 2 times something. Plus, I know this interval is a gap of 3 times something. I know this interval is a gap of 0.6 times something. And I know this interval is a gap of 1.4 times something. That's the way he thought about it. If you like that, go with it. And then I'm looking at the right side this time, and it's height. So that's 3. The right side, that's 1. The right side, that's 5. The right side, that's 8. So what do we got here? We've got a 6 plus a 3 plus a 2 point. 6 plus a 3 plus a 3 plus a 8, 11.2, I think. Yeah, if I'm wrong, sorry. What's that? That's 12, 24, so that'd be 23.2. Yeah, pretty close to those two. All right, let's talk midpoint. Now, this one's kind of interesting. The midpoint formula. Well, we've got a problem. I mean, we can break this up so that we can create a midpoint, right? So that I could have a middle, I should say. I shouldn't say a midpoint, but to have a middle. We could do that, but the problem is, what's halfway between 1 and 6? Not 3, right? What's halfway between 6 and 8? Not 6.6. So we run into a problem here. We can't do this. So the midpoint is not possible. Based on the table that they gave us, it's just not possible. Trapezoid, let's practice it the long way. I'm going to be interested to see if it turns out to still be the average of these two. So let's see if it's 23.4. But let's do it the long way first. Why did I write 6? T sub 4. All right. So this is going to be a height of 2 times these two added together, right? Yeah, 3 plus 3. Plus, this is going to be a height of 3 of these added together. Plus, this is going to be a height of 0.6 of those those are my bases. That's why I don't know if I'm explaining that very well, but these are my bases. This is going to be my height. This is base 1. This is base 2 because this is the left side. This is the right side. Plus, my gap is 1.4 times 5 plus 8. So that's 2 times 6 plus 3 times 4 plus 0.6 times 6 plus 1.4 times 13. Yeah, that's the one that's going to get me down. So that's 12 plus 12 plus 3.6 plus, yeah, well, 14 squared. Let's do it like this. 13 times 13 is 200 or 169, right? Yeah, 169 plus another 13 would be 179, 182, but I got to move the decimal point over once, so it'd be 18.2. No. Yeah. Well, this is no way it's going to be half of those, is it? That's 24. Deep, bop, boop, beep, boop, bop, boop. What did I forget to times all of this by? 1/2. So now maybe it will end up being, because the trapezoid formula is 1/2 times width times base 1 plus base 2. So let's see. We get 1/2 times, this is 24 plus, that's going to be what, 21.8, which equals 1/2 of 45.8, which ends up being 2 goes into there twice, 2 goes into there twice. I messed it up, I bet. I double checked on the calc, and it did come out to be, it wasn't what I thought. 22. It came out to be 22.9. So if something's up with that, let me know. I tried to do some calculating over there, but all right. Anyway, can any of these be approximate? Could any of these approximations represent the approximate area of the region? The answer is no. That is not possible because we don't have that hint about. So I'll write part B down here. No. F of x, I'm going to say, is not less than or greater than 0. So that means that our function isn't always above or always below the x-axis, which means that we could have some transitions, which isn't going to allow us to calculate those areas. And then the last one, approximate f prime of 7. So this is, you only have one choice here, so I'll leave you pause. Try it on your own. What's a good approximation of f prime of 7? All right, our hands are tied. We can only use these two. So f prime of 7 is approximately 8 minus 5 over 8 minus 6.6. 8 minus 5 is 3. 1.4, which equals 30 over 14. Moved over the decimal point one time. Divide by 2, 15 over 7. Yeah, close enough. All right.